Hello and welcome to this short video on Mohr circles. The goal of this video is to show you how Mohr circle works, how they could be useful for you, and to make some interesting observations as well. So first of all, Mohr circles is a graphical way to find the principal normal stresses and the maximal shear stress of a given stress state, which could be the one right here, where you have some normal forces acting on sigma x, y, and z, and also some different shear stresses, the taus you have here. This stress state could also be shown using a tensor, a stress tensor, which is shown right here with this symmetric 3x3 matrix. It has to be symmetric because we don't want to have any moment acting on our stress element to prevent any rotation. And also, of course, we're using an isotropic material. So I'm going to start with the 2D Mohr circle, simplest one. So now obviously my stress element is a square where I have sigma x and sigma y as normal forces acting on it, and the shear stress tau x y. So now let's move to the Mohr circle itself, and I'll explain you how to draw it. So first of all, I have to put my two stresses on my graph right here, where I have normal axis right here and shear axis right here. So I'm gonna take sigma x, which is displayed right here, and tau xy, which is gonna give me my first point right here, and then sigma y and tau yx, which is the opposite of tau xy, and this is gonna give me my second point right here. Now I'm gonna say that this is the diameter of my Mohr circle, and this allows me to draw the actual Mohr circle right here, as you can see. Now I see that this Mohr circle crosses the normal axis on 2 points, the two green points that you see right here. And these are my principal normal stresses acting on my stress element. And I can actually also get from the Mohr circle the angle, how much I have to turn my stress element to get this principal normal stresses. And it's important to remember that the angle I see on the Mohr circle, so this angle here, is actually twice the real angle I have to turn my stress element by, which is shown right here. And then I have a blue point here, which is my maximal shear stress. So this maximal shear stress, as you can see, is the radius of my Mohr circle. And again, I have an angle of maximal shear stress, which is displayed right here. And again, the angle on my Mohr circle is twice the real angle. Now, some interesting observations we can do right here is that even if I don't apply any shear stress to my stress element, I will still have some maximal shear stress. And as you can see, the angle of the maximal shear stress is, well, 90 degrees on my Mohr circle, but in reality 45 degrees. And as you probably already know, if I'm doing, for example, tensile stress, then my maximum shear stress is going to be on a 45 degrees plane. Now, the only way to avoid having any shear stresses in my stress element is actually to have sigma x being equal to sigma y. And that's the only way I can avoid any shear stresses. Now, the other way to get my principal stresses would be to get the eigenvalues of my 2x2 stress tensor. And that's what we're going to see later for the 3D case. So in 3D now, what I have to do is get this principal normal stresses by, as I've told you, find the eigenvalues of my stress tensor, which is right here. That's a random one I've chosen. It's symmetric, as I've explained to you in the beginning. And finding the eigenvalues gives me my actual principal normal stresses sigma 1, sigma 2, and sigma 3. So now let's move to the 3D Mohr circles. So it's the same principle, but now I have 3 principal stresses instead of 2. So I also have 3 Mohr circles instead of 1, because I have one Mohr circle between sigma 1 and sigma 2, another Mohr circle between sigma 2 and sigma 3, and a bigger one between sigma 1 and sigma 3. So now the orange zone right here, same at the bottom, is the allowed pairs of stresses, sigma n, the principal normal force, and tau, which is my shear force, and the only allowed pairs of normal and shear stresses are in these 2 orange zones, because it has to be inside the bigger circle and outside of the 2 smaller circles. Now the observation we can do here is that first of all, the maximal shear stress only depends on the difference between the smallest and the largest principal stresses. So as you can see, if I move my sigma 2, which is the middle one, well, my maximal shear stress doesn't change at all. And the other observation we can make is that if I equal sigma 3 to 0, as it is right now, and this would be the same actually, or almost the same, if we look in 2D as the example I've shown you before. But actually, the fact that I'm now in 3D and that I, even if I don't apply any force on the z-axis, any normal force, well, this still has an influence on the maximal shear stress, because in 2D my maximal shear stress would lie right here at the top of the first gray Mohr circle, but now because I'm in 3D, my maximal shear stress is actually a bit higher. And now there's actually another way to get this principal normal stresses using Mohr circles. So instead of, as I've done it here, get the eigenvalues of my stress tensor, I can actually use projections. So I have my 3D stress tensor here, and what I'm going to do is project it on along my x, y, and z axis. So that's, for example, projection on the z-axis, and what I get is a 2D stress tensor. So doing this, what I get, again, of course, is my 2D Mohr circle, as we've seen at the beginning of this video. And that's, for example, the projection along the x-axis. And I, again, get my principal normal stresses, the 2 green points, and my maximal shear stress, the blue point right here. And what's more interesting is to see, for example, the angle of principal stresses, which is -19 right here, and so half the angle between the red line here and the normal axis. And doing 3 different projections along the x, y, and z axis, I get 3 different angles. So here, that's another one, and that's the third one. And now, if I actually apply this angle, so if I actually rotate my stress element by -19.9539 degrees around the x-axis, I do the same around the y-axis, and the same again around the z-axis, then I actually get my new set of coordinates, or where I get my principal normal stresses on acting on my stress element. So I would get again these 3 values up here, just by applying 3 rotation I've found by projecting my stress state on my 3 different axes. So that's it. I hope you enjoyed the video and actually learned something on Mohr circles. Thanks for watching.